So this is problem 3-4 in the AP problem pack. It starts off with the diagram. It's a student pulling a box that's 100 kilograms. The only other thing they give you is this is a rough surface and that the position x varies with time t according to x equals 0.5 t cubed plus 2t. So part A, determine the speed of the box at times t equals 0. The speed or velocity is equal to the derivative of the position. So if you just take the derivative of this, you get v equals 1.5 t squared plus 2. And then if you're trying to find v at times t equals 0, you just plug in 0 for t and you get v of 0 equals 2 meters per second. Part B, determine the following as functions of time t. The first one they want you to do is the kinetic energy of the box. Kinetic energy is equal to 1/2 mv squared. We have m, and we just found v as a function of time. So if we just plug those in, k equals 1/2 100, 1.5 t squared plus 2 squared. That simplifies to 50. 1.5 t squared plus 2 squared, and that's your kinetic energy as a function of time. And next is the net force as a function of time. That's net force is equal to ma. We have m, but we don't have a. But a is equal to the derivative of the velocity as a function of time. So then if we just take the derivative of this, we get 3t. So now that we have a, we can just plug those in. F equals 100 times 3t. So f as a function of time is 300t. Part 3 of this, the power being delivered to the box. Power is equal to the force times the velocity. And we just found force as a function of time, and we already had velocity as a function of time, so if we just plug those in, 300t times 1.5 t squared plus 2, that simplifies to 450t cubed plus 600t. Part C, calculate the net work done on the box on the interval t equals 0 to t equals 2. Work is equal to the integral of power over time. We just found power, so we can plug that right in. Work is equal to the integral of 450t cubed plus 600t dt from on the interval 0 to 2. That simplifies, or if you solve that, 454 plus 0 to 2, that equals 1800 plus 1200. So your answer is 3000 joules. Part D, indicate whether the work done on the box by the student in the interval 0 to 2 would be greater than, less than, or equal to the answer in part C. Well, part C is just the work done on the box. So the student does the work on the box. So if you take the box and the student, the forces are the student pulling the box and the frictional force done by the ground going against it. So the work done by the student not only pulls the box, but also has to overcome the force of friction going against it. So the work done by the student is equal to the work done on the box plus the work done by friction, because he has to overcome that work. So part C is just this part, so adding this would make it greater than. The work done by the student over the interval 0 to 2 would be greater than the answer in part C.